Let's go through liquid 2537. Count the number of good subarrays. For this question, it gives us an integer array and the number of k. Return the number of good subarray of nums. And it defines a subarray. Good subarray, that is, if there is index ij that I does not equal to j, right? So, and also it has array I equals to array j. For this kind of array, it need to have k pairs, right? At least k pairs. So let's look at the example. This 1, 1, 1, right? So if I equals 0, j equals 1, there is one pair. Y is 0, j equals to 2, the one pair. 1, 0, 3, that is one pair. Or 0, 4, that is one pair. And 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, 3, 4, right? So there are totally, this is 10 pairs. So, so it has only one subarray which have 10 pairs I and j, which have I smaller to j, and array I equals array j. So this return 1. The second example, k equals 2, right? So we know 3, 3, that is one pair, and 2, 2, that is one pair. So we know at least this subarray is a pair, right? If this is one pair, any subarray include this element, that will also be one pair. So we know this one is one pair, right? And also we know when we move this one to 4, and we move the right pointer to this 4, right? And this one to be 1. This is also one pair, right? So we can shrink the left pointer, trying to see this is another pair. So totally there are 4 pairs. 1, 2, 3, and 4, right? 4 pairs. So for these questions, we know if a number appears k times, for example, if in a subarray, here, right? If a number, for example, this is 3, it appears 3 times, okay? So we know this kind of 3, it will contribute 3 pairs. That is 3 multiplied by 3, j minus 1 divided by 2, right? It will contribute 3 pairs to the counts. So if, for example, this appears 4, that is, it will contribute 6, right? So we know if in a subarray a number appear, the frequency is k, they will contribute k multiplied by k minus 1 divided by 2, right? And in this kind of subarray, we have some other numbers. For example, 4, right? 4, if it appears 3 times, so we know how many pairs total. That is the contribution from 3 plus the contribution of 4. If there is some other numbers which appears, I also added the other contributions. So for example, the contribution from 3, it can contribute 6 pairs. Contribute for number 4, it will contribute 3, right? And for example, there is some kind of 2 here, right? So it will contribute 1. So totally will for this subarray, it will contribute 10 pairs. And also for any subarray include this this kind of array, elements, it will also contribute 10 elements. So what we think about is that we can use a map, and the key will be the value. For example, we'll put 3 into it, right? the value also will be an integer, map of integer, integer. The value will be the frequency. So we use a right pointer here. For example, we have here, right? So we this right pointer, when we move to the right, we find out another 3, right? So we know this kind of number 3 appears twice, right? So we can update this map, and also the total counts from this kind of we'll say sliding window, right? Sliding window, it will contribute 1 times. That is, for example, if originally this value has k, right? And now it has become k plus 1. So that is 2 multiplied by k plus 1 multiplied by k minus 2 k minus 1, right? So it will be k, right? It will contribute k more pairs. So on the right. So so actually the so in our map we are put so those kind of values and its frequencies. So every frequency, if it increase, we will know it will count more pairs. And if for example the right window, we find a position, it already counts k pairs. Then we know the subarray will be every element from include the right and to the end, right? So if we find one, we'll have a total counts. Total counts will plus equal to less n minus right. Okay. So this is the right pointer, and if we find right pointer, we can shrink the left pointer, right? So if for example we move up 1 3 out, right? The same thing here is that originally the key is 2 k minus 1, right? And now those frequency become k minus 1, so it will multiply k minus 2 by 2, right? So we'll remove k minus 1 element from our total counts if we find one which appears on our map. So in this case, we use map and a sliding window to do these questions. So let's begin to write code for this. Let's get int a equals nums of less. Okay. So we'll say we'll have a map. The key will be the value, and the number in nums. Okay, the value will be the frequency. So we'll have 2 pointers. We have left equals 0. And total, we need to use a long, right? Long equals 0. We are use count as those kind of pairs in the sliding window. Okay, we use long here, and we are also have result because this is also long type. So what we need to do, this is how many pairs in the slide window, and this result is our how many subarrays, right? So we'll say for int right plus arrow right smaller than n right plus plus. Uh, so we'll say we'll have map put map hit. Let's do this. Int count. Let's call right count. Subarray count. Okay. Increased. Okay. We call we call the counts for this kind of value. Okay. So we'll call right number count for count for count for count of number equals map it or default nums right. Yeah, right. So first thing is that we need to put nums right count for number, right? And we know this sliding window, the counts will plus equal to this count for number minus one, right? This is the right index. Okay, so let's say for the left, while let's say this count is greater equal to k. Okay. We'll have left plus plus, right? So we know right number counts for right number will be much better. Right number, right? Count for right number. And we know the count for the left number. Count left number and count for left number. Let's map it for default. Actually, it will not be zero, right? Because this map we already calculate, so we'll just get will be enough left. Okay. So we'll say we'll count square minus equal to sorry, I think this one we should add equal to count for not for right. The reason is that for example, this kind of three it already appears 4 times, right? 4 times. So if we add another these numbers, okay, what increase it will be four pairs, because we add a new one which can for each of the previous one we can create a pair. So the first is 2 n plus 1 multiply n minus 2 n minus 1. That is n, right? So also when we added that the previous one, every one in the side window we can form our actual pair. So it will be just kind of right. But if we remove one out, it will minus this kind of n minus 1, right? So because there are n minus 1 element can form the pair with the one removed out. So will be count for left number minus 1, right? Okay, and here, if this kind of counts is greater or equal to k, our result will add a plus what? Add a plus n minus right. That is for the right. This is a minimal sliding window which can have k pairs of the this k pair, right? And every element, including this kind of elements, every subarray which has more element to this, so it will also satisfy these conditions. So we'll have n minus right. So there are n minus right combinations. If we move the right point, so this will result plus equals n minus right. In the end, and left plus plus. Also, we are right. Count because we remove the left one, remove one element out, minus. Yeah. If count for left number equals to 0, map remove this key, right? Remove with nums, right? Else we'll just update map put nums on left count for left num. Okay. Here what we put is plus 1, okay, because we increase 1 on the right, right? In the end, we just need to return the result. Let's take some other examples. And my submissions. One thing to notice is that the result need to return long. So for this kind of approach, the time complexity will be over n, space that is map that is also over n linear.